Find minimum time to reach last room part 2. So this is an easy problem, right? It can be solved in just changing a variables, right? Changing some variables in the previous question. So there is a dungeon with n into m rooms arranged as a grid. So if you want to look how does a dungeon look like, so this is how a dungeon look like. So we are given with n into m rooms arranged as a grid, something like a matrix. Okay, same as it is. Now we are given a 2D array move time of size n into m, same as dungeon, where move time ij represents the minimum time in seconds where you can start moving to that room. So start moving to that room. So here you are, and here to come to this room, let me take an example like you got only x seconds. Now to reach this room we need something like y seconds. So you need to wait till y seconds to reach to that room. So how much time you need to wait? Y minus x. However, we are not considered with this y minus x. We just go and wait till y seconds and then increment plus 1 in the previous problem. But here there is a problem that you can start from room 0 comma 0 at time is equal to 0 and can move to an adjacent room. Moving between adjacent room takes 1 second for one move and 2 seconds for the next, alternating between the two. So first time, right? So think like there are four rooms, right? There are something like, okay, 5 rooms. I am taking 5 rooms. Now to move from here to here, it take 1 second. So 1 second firstly, and then 2 seconds here, and then not 3 but 1 second, not 4 but 2 seconds. So alternatingly, first 1 second, then 2 seconds, then again 1 second, then 2 seconds. Okay, I think it's clear for you now. Return the minimum time to reach the last room n minus 1, m minus 1. So if this is my grid, I am starting over here, then I need to move somewhere, and to reach this room, the last room, n minus 1, m minus 1, what is the time that will be taken, right? Two rooms are adjacent if they share a common wall, either horizontally or vertically. So either horizontal, sorry, either horizontally or vertically. A wall between horizontally or vertically means there is a room like this. There will be a room like two rooms adjacent rooms like this. So I can go to the right, I can go to the bottom, I can go to the left, I can go to the top. So if this is my room, I can go to this room. If this was my room, I can go to this room. I can go to this room, and I can also go to this room. I think it's perfect now. Two rooms are okay. Now we understood the question clearly. Now here we are given with the examples, however we go to them. And the constants are move time dot length and move time of I dot length are 750, which are even low, not compared to 1e4 or 1e5. So they are just less. But move time of ij is less than or equal to 1e9. However, it doesn't going to make any difference, right? It can also be take we can only take int data type instead of long. So let us go to the first example. Here I am starting with the time of 0. Okay, I have started with the time of 0. Now I can go to the right, to the bottom. Can I go to the left? No, if there is no room to the left, right, so I cannot go. To the top I cannot go, so there is no room, so that I cannot go. Now to go to the right room, I need I need 4 seconds, right? But I just have 0 seconds, right? And cost is nothing but what are we adding? either 1 or 2, right? Here if you see, I am adding 1 and then 2 and then 1 and then 2, right? So that's how the cost initially, as I said, 1. Okay, I have to wait till 4 seconds. Okay, I am waiting till 4 seconds. Now, how do I know that I have to wait till 4 seconds? Right? Imagine, just imagine, in somewhere in the middle of this grid, I got 5 here and I need to move to 4, right? I move to 4 and I have a 5. Now, this is the right cell, right room to the right. Now, I need 4 seconds to move to this cell, right? I need 4 seconds to move to that cell. Now, wait time or arrival time will be arrival time. Arrival time will be, what will be the arrival time? So I need 4 seconds, but I already have 5 seconds, which is maximum, right? So I will be taking maximum of 5 comma 4, something like this one and again this one. I'll tell you what will it will be in the algorithm, plus the cost either 1 or 2 to move to that cell. Either the cost will be either 1 or 2. Now here I have 4, right? I have 4. Now I need to move to that 4 with something like the cost of 1. 4, the maximum from 0 and 4 is 4. Maximum of 0 comma 4 is 4, plus cost is 1. Okay, here the cost will be 1. So 4 plus 1 will be 5. The time here is 5. Now I can move here, but I cannot move here. I cannot move here. But if you see, I am not taking any visited matrix, right? So I can move here. But here comes the actual logic. So if I moved here, the time here, the time where I came from is 5. Okay, the time where I came from is 5. Now, the distance of this cell, here I am checking the time, and here I am going and checking distance, nothing but here I'll store a distance matrix. Sorry, I have forgotten to tell you that here matrix will be storing a distance matrix. So that distance matrix will be having 0. So if the time is greater than, if the time is greater than distance, that means I am visiting the cell which I already visited. That means I am going in the reverse order. That means I am going to the reverse order. I am going far away from the target cell, which is the last room, right? So that's why I, even if I go to the left, then I will just skip that part. Now I am going here. So as I said, 5 and 4. Here the time is 5. If you see, the time is 5 and the time is 5 and moving to 4. Moving to 4, I need the maximum of where I am starting and where I am going. I am going from 5 to 4 and the maximum of 5 and 4 is 5. 5 plus the cost. Now the cost will not be 1. Instead, it will be 2. Okay, I think it's clear. Right. 5 plus 2 will give me 7. 7. Here it will be 7. I think it's correct, right? Output is 7. Now let us go to the another example. First thing to know the cost will be 1 or 2. I'll do one thing. First, I'm starting with 1. So the steps will be 0. I am taking a variable, steps will be 0. Now cost will be steps mod 2 is equal to 0. Mod 2 is equal to 0. Then I will add, I will add what I have to add then. I have to add 1. If not, I will add 2, right? The cost will be 2. If not, if it is even, the steps are even, then I will add 1. If the steps are odd, then I'll add 2. This example, I'm starting with 0. But what I said is I am storing this distance matrix. Now, the question is, what does this distance matrix store? So, distance matrix store the time to reach a cell in the matrix or grid. Okay. So, I will return distance of n minus 1 and m minus 1 at the end. Now, how will the distance matrix will be created? So distance matrix will be the same as the given grid, right? Wait, sorry, the given grid, right? This is the distance matrix and this is the given grid. This is the grid, this is the grid, and this is the given, this is the created distance matrix. Now, let us start our let me start with the steps are initially 0 and the cost what will be the cost? I'll tell you what it will be. The cost will be okay. Now at the last I'll the arrival time, as I said, the maximum of the cell where we started and the cell where we ended plus cost. Okay, for now it's clear, right? Now where I am starting at 0. Okay, I am starting at 0. Now I want to go to the right cell and it also have the minimum time to reach that cell. Minimum time to reach that cell is also 0. What is the cost? Cost is steps mod 2. If it is equal to 0, it will be 1. Yes, it is 1. Now it is max is 0 plus the cost is 1. So it will be 1. Now where I have to store this actually I need to store this here and it is 1 distance. Now you might be wondering, right, what is the use of storing this distance and why we how we avoid going reverse. That means why we are not seeing the same things, not seeing the same cell again. Now let us take what you are doubting with. Let us go here. Now the time where we started, as I said, the time where we started and the distance where the cell is going, that means where the cell we are going, the time is here 1 and the distance is here 0. If the time is greater than the distance, I need to skip that uh, that traverse, right? So I am skipping the traverse. I cannot go to the top as it is going out of bounds. I can go to the right. So but if I go to the right, I need to take 1 here, 1 2 3 and then 4. But if I go here, I'm just assuming here 1 2 3 and then 4, but here 1 2 3 and 4. So there is nothing like you can go here and here, nothing like that. So if the if the values are not equal, then we can consider going there and there, right here. But the example is given that to go from here to here, but no need. So here I am going here, but the steps are increased and the steps is equal to 1, and where I'm starting at 1 and I'm going where it is 0. The maximum of these two is 1, and what is the cost if mod 2 1 mod 2 is equal to 0? No, that's why the cost is 2, right? As I said here, steps mod 2 is equal to 0, then add 1 to the cost. If not 2, right? The cost is 2. 1 plus 2 will be 3. So it will be 3 here. Now I am not gonna store this here. I'll be storing here in the distance. Now I can go even here, but there is a waste of time. But I'll go here, but instead, but before that, I will change the steps are incremented and the cost is 1 again, and the maximum of, I'll tell you what will be the change. Now here I have where I am starting with 3. I am going to 0. Now maximum of these two is 3 plus the cost is 1. Okay, 3, and here I am going to 4, right? Okay, 4. Now the steps are incremented the steps are incremented. Steps, wait a second, steps are 3, right? Mod 2 is not equal to 0, so it will be 2. Now I am starting at 4. I am going to 0, and the maximum of these two is 4 plus 2 will be 6. So here I am going here, it will be 6. Now I have reached, actually I have reached this cell. Now I'll simply return that. But here also I'll be using the same thing. Here I'm starting with 0 and adding 1. So let us consider this example and let us start solving it. Right? I will be storing a periodic queue, and I'll store in this periodic queue. Right? I will store the time. I'll store the time. I'll store the steps and the indices x comma y. Okay, I'll name it as x comma y. So this is how I store the priority queue. 0 is the time to arrive at the index 0 comma 0. So to arrive at 0 comma 0, the minimum steps I took is nothing but 0. Now the time is also 0. Now what I'll do, this priority queue do, is taking the minimum time every time. So every time at the top, it will be placed at the top. Now I am taking this cell. Now I'll go to the right, I'll go to the bottom, and I can't go to the left and also to the top. Okay, now the steps what I got is 0, and the time which I got, the time which I got is also 0, and the cost which I got is steps mod 2 is 0. If it is 0, then the cost will be 1. Now, after that, the time, arrival time, which I send into the priority queue after some time, arrival time will be maximum of the time which I took, the time which I am starting with, and the time where I am going, plus cost. Okay. Now it is super clear. Now going to 1, where I am starting at 0, where I am going is at 1. The maximum of 0 comma 1 is 1 plus 1 is 2 comma where I am. The steps will be incremented every time. Steps plus 1, and where I am going 0 comma 1. If let me give the indices, the index will be 0 comma 1. Now the same things again, but I am going to 2. I am just changing it. I am going to 2. That means I am going at the minimum time required is 2. So the maximum of 0 comma 2 is 2. 2 plus 1 is 3. 3 comma the steps are incremented by 1, and which index I go 1 comma 0. Okay, now this will be removed. Now I have another thing to remove, 2 comma 1 comma 0 comma 1. So the steps are 2. If the steps are the steps are 1, and the cost will be steps mod 2. If it is equal to 0, it will be 1. If not, it will be 2. So the cost will be 2. Now where I am starting, I am starting with the time of 2. Now I am starting with the time of 2. So maximum of time is 2. Time is 2, and where I am going, where I am going, I am going, let me tell you where I am going, right? So I am at this, right? But before that, what, as I said, distance will store the time where the time to reach that cell. Distance will store the time to reach that cell. So let me change it. Let me change it, right? So let me change it. So at 1, 0 comma 1, I got 2. At 1 comma 0, I got 3. At 1 comma 0, I got 3. Okay, now I am at 2, and if I even go here, I have 0. So the distance, if it is time lesser than time, then just skip it. So I am going to the right, and I am going to the bottom. If I go to the right, the minimum time required is 3. So maximum of 2 comma 3 is 3. 3 plus 2 is 5. Okay, 5 comma. Now the steps are incremented by 1, and where I am going 0 comma 2. Let me not forget to change 0 comma 2 here. So uh, it will be the time will be 5. Now I have the bottom also 2 comma 4. The maximum from 2 comma 4 is 4. So 4 plus 2 will be 6. So 6 comma, the steps will be incremented by 1. 6 comma 2 comma, where I am going here, 1 comma 1, 1 comma 1. So at 1 comma 1 it will be 6. At 1 comma 1 it will be 6. Okay, which I need to remove is 3. 1 comma 1 comma 0, I am removing it, and the steps are 1, and the time, sorry, didn't change this time is 3 now. The time is 3 now, and the cost will be the same, 1 mod 2. If it is equal to 0 it will be 1, if not it will be 2. So now the time is 3. So the time where I am going from is 3, and where I am reaching it will also be mattered, right? So where I can go, where I can go 1 comma 0. First thing, how the priority queue will be is priority queue will be of tuple int and then int. It will be a priority queue. Okay, the minimum will be at the top, and according to your language you can change it. And first thing, push, or yes, pq dot push. First thing, what it is, 0 comma 0 comma 0 comma 0. Now I have distance matrix of n into m size, which is equal to the given grid. Now while PQ is not empty, now I need to do something. So auto time comma steps comma indices, something like x comma y, right? Which are I and j, is equal to pq dot pop again. Now I have time. If, as I said, as I said, time, if it is greater than distance of x, y, then continue. Now I have to go +1 and going to the left, right, top, bottom. So for that, for auto dirs, going to every direction, right? Dirs in dirs. So for auto direction in directions, now I have new x is equal to x, sorry, is equal to x plus dir of 0, and new y is equal to y plus dir of 1. Okay, new x, new y I got. If nx is less than 0, or ny is less than 0, or nx is greater than or is equal to, what is the number of rows? Number of rows are n, I think. Okay, and or ny is greater than or equal to m, then continue. Now if not, then the cost will be steps mod 2 is equal to 0, then it will be 1. If not, it will be 2. Now the arrival time will be the maximum of the time which I got, and the time where I am going. So it will be something like grid. So grid of x, sorry, nx, and where I am going, ny, plus cost. Okay, this will be our arrival time. And pq dot push, what is the time, arrival time, and the steps will be incremented by 1, and then nx, ny. That's it. So after this while loop, then after this while loop, you need to return -1. But where is the answer, right? So it will be at here, if x is equal to n minus 1 and y is equal to m minus 1, return time. That's it. So this is the simplest form of code, I think. So this is the code, and you can look at the code here. Also, I haven't said you this dirs, and this tuple is initialized using t, and here I have distance matrix as a set. Okay, and here I will be giving the code link in the description, and you can check it. And if you like this video, do share it to your friends and do subscribe to my channel. Thank you.